with bad data that goes in, there's going to be bad results that come out. And we're just kind of setting ourselves up for that again. So the models exist, the science exists, we know how to do these things. If you have a good foundation, the rest of that will follow. I was always kind of curious about the way the world worked. And I think maps just helped me visually see that. It was just seeing the interconnectedness of the way things work and how places and countries and cities and all these different things kind of worked together. So I didn't even know it was spatial thinking, like in the classical sense, but I was thinking about how those things worked together. I went to school and I didn't really know exactly what I wanted to do. The advisor said, go check out the geography department. There's a big hill at University of Wisconsin, and I was like at the top of the hill, said go down the hill, here's the building, you walk in, and just got some more information. It kind of started to click there. You walk in, it's a beautiful old building, there's literal maps all over the walls. I'm like, okay, this kind of seems like something I might be interested in. I took 2 of their classes, and this was the advanced course, if you will, for visualization and cartographic design. Eventually I landed on this project to kind of recreate an election map. This map, if you wanted to make it now, you can make it in 5 minutes, but at the time I had to manually color every single county in the United States. So there's some 3,000 counties. It took hours and hours of work. And I finally brought it in, and Professor Harrower, he was like, Pete saw it, he's like, this is great. There's like, you kind of took everything we talked about and put it on paper. And the TA who I looked up to a lot, who was helping me, like they kind of the same thing. It was one of those weird moments where I was so unsure of like what I was doing, but then to get the validation and feedback to say like, oh wow, I can actually kind of pull this off was really cool. I was fortunate enough to kind of still do some mapping work and stuff with GIS as I was going along. I wanted to keep it going. I really enjoyed it. I was able to do a little bit of it in that job, which was great. They kind of encourage you to do that, but there were like a few different things that I kind of saw that, again, you could still do this. So I came out and was working a job back in my hometown in Minneapolis, and I was fortunate enough to kind of still do some mapping work and stuff with GIS as I was going along. I wanted to keep it going. I really enjoyed it. I was able to do a little bit of it in that job, which was great. They kind of encourage you to do that, but there were like a few different things that I kind of saw that, again, you could still do this. So Minneapolis has this weird downtown skyway system. It's like tunnels above ground connecting all the buildings. And I was living right downtown and actually used that to walk to work when it was freezing cold outside. That's the whole point of them. But there's no visualization map to get around there. No one had built it. So I just built it in a style that I thought would work, which was like a subway map. I did that. I posted on Twitter at the time, and all of a sudden it was like ending up in, all over the place. All of a sudden people really wanted to actually interact with that. And it gave me like kind of a confidence to say, okay, this is something interesting. There's some sort of value to it. And people are really curious about it. The next thing we did, I was working with a business partner at the time, was actually we got Asheville, North Carolina, the city reached out to they wanted us to build their bus map. So all of a sudden we're going from this fake thing I kind of built and shared on the internet to an actual city that wants a bus map built for them because they like, some of that work that we did. So it quickly became, okay, there's people actually want this, and it's something I can do. I didn't know the technology side of it. It felt like, like I could put the frosting on the cake, but I couldn't bake the cake itself. So it was at that point, it was like either I figure these things out and it's going to be a very unclear path. I had written some things before, but I never really like blog posts and stuff like that, but never really kind of just started sharing it on a regular basis. So it was about, summer of 2021. I posted something like, here's my favorite Python libraries and, the number of downloads that they get. And I posted that on LinkedIn, and it was like, people started liking it like all over the place. And it was crazy. So I did it again and again. That's really where it started, was like, I just wanted to kind of share some of the things that I was thinking about, share my perspective on how things were done. Who I was creating it for was me minus 7 years. Like when I was starting my journey to say like, I need to learn this technical stuff. I need to learn SQL. I need to learn Python. I need to learn, cloud. I need to learn how data works. I need to learn how to build applications. I started building content for that person. The other big thing is that there was nobody else talking about it. Stuff I was reading specific to geospatial. There's stuff about web development, there's stuff about data science, there's all these different resources. But there was nobody kind of saying, here's how I blend it with the perspective of, maps and geospatial and stuff like that. So that's where it started from. And what's cool is now I get people sending me projects that they built, from all over, all ends of literally really wild stuff. But it's been cool to see kind of the reach that has. And it really just came from I liked sharing and seeing aha moments. And now I get to do that in a much bigger setting. A lot of people try to jump right to the end, right? You want to get the map, you want to get the application, you want it to look good, all those different things. I've done that plenty of times in my career where you kind of jump to the end and then the data piece looks like the Wizard of Oz in the background with all the, pulling different levers and trying to make it work. And yeah, if you get it done once, that's great. What you really need to do is make it repeatable and manageable and scalable. So if you put more time into the bottom layers, the rest of it will work on the top to, kind of make it scalable and efficient. So I always start with a few basic choices like where's your data coming from? How are you storing it? And what does it need to come out as, right? What are the formats you need? And I've made this mistake plenty of times where you do it just to get it done. You're going to end up ballooning the cost or, it's going to be not time efficient or any of these different things. And really what matters here at the end of the day is if you need something that's updated every several minutes or even every day, you want to have an efficient, repeatable process. So I always say pick the right formats, pick the right process, design the right outputs, pick scalable cloud services and orchestration tools. Where I think you want to look at specific systems that can help you advance and scale is really around if you need to go to a larger scale or a more detailed scale, which kind of sounds contradictory, but if you have a large geography, like Australia is a pretty big place, you can't just do a simple query and expect it to work there. You need systems that manage that. If you need a more detailed scale, that could be frequency of the data, and you have to do that over and over and over again, or it's very small and granular. You could, a lot of satellite imagery might come in at 30 meters. Now, all of a sudden you need 2 meters or better to get a more detailed image. That balloons your compute and infrastructure costs. So picking specific data systems there that can handle that is going to be really important. Once you've done all that, then you can connect it up to any of the things that you need to. That could be a business intelligence dashboard, that could be a simple report that gets sent to someone, that could be a full-scale mapping application or something on your phone. The choices there become endless. So it's really about that design phase at the bottom, picking the right ways to do things, and you can really make that scalable and grow. So I tend to err on the side of reliability. If you're getting, and there are certain systems that require a high volume of data, right? And really knowing what those things are and when latency is acceptable, right? If I'm getting an update every 15 minutes, is that okay? A lot of times you hear real time and it's really like, well, maybe every hour if I got an update, that'd be fine. So I tend to make sure that the data is correct and presenting a clear view. And if you do that first, then you can slowly reintroduce speed into a system. So I think reliability is really important, and especially with location data, like there are, big decisions that you can be making off that data in terms of how you respond to something, or where there may be some sort of, crisis event or something like that. If you think about climate issues, things like floods and fires and all these different things require a high amount of accuracy, and a small mistake in that could be a big issue. So you want to have well-designed resilient systems that put forth a clear view of the truth as you have it. And then you can start to kind of add some of the other pieces into it as you progress. But I try to boil it back to there's real world, business consequences, and there's real world human consequences, right? We have to balance both of those and understand if your data is not telling you a full picture of the story and telling you specifically where, right? All these things could happen, but if we can respond better and faster with that, that's really important. Floods, all these climatic events represent massive amounts of, damage and cost to the economy. If we could get better at just doing a little bit of that, there's a huge impact in terms of how we respond and handle this different thing. When you talk about cost of a spatial pipeline, like just those few things could be a dramatic change that for impacting people and impacting your business. Being able to observe what's happening with your pipelines is important. It's not just traditional like observability of, data volume or, understanding, issues of correctness or anything like that. I think it's really just getting a visual view and validation of what that data is coming in. If you're in geospatial, you probably have heard the term null island, which is data that's geocoded incorrectly. It's up 0 latitude, 0 longitude in the middle of the Atlantic Ocean right off the coast of Africa, right? Just being able to know, like, are you seeing a large number of nulls come in? Are they going to the wrong location? Is data coming in the wrong projection system, right? Like that's another huge issue. If you have data that is coming in as decimal degrees and all of a sudden you have a projected coordinate system, your data is going to be off. And I see that time and time again. And again, all these different formats use different methods of bringing that forward. So just having a way to not just inspect like the outputs or the throughput of a pipeline or anything like that, but also have a validation step, either a spatial correctness validation step, a projection validation step, and a visual validation. Again, I go all the way back to maps and just seeing what's there. Having a visual inspection of your data is going to be really important. So pushing that through to understand what's coming through, where the gaps are, anything like that is really important. That's a data quality issue to a certain degree, but you have to design good, I talk about it as data contracts, right? You explain to the end user what they can expect from this data set. If there are potential risks with cloud cover or missing data or things like that, you need to very clearly explain that and showcase that in that application that they're using, right? That's something I see that's a miss quite a bit, where people don't have a clear data contract about what they can expect coming from that data. This data is updated on this frequency. There may be issues in latency. This will, even just explain to them that there's a data status, green, yellow, or red. What's happening from that perspective, and can they see what's happening there? There's things that you can do to fix that intermittently and kind of cause issues, but if you have a sudden spike or drop in that data, you haven't validated the data correctly, now you're telling someone a signal that isn't there, that's going to be a big problem. So you need to have that design phase where you're going from raw data to data that's being pushed to a dashboard and discoverable. That's going to be very clear about what those expectations are. And that's something that is really new for geospatial, right? I think like a lot of the times government agencies are doing this, they're pushing that data. It's kind of out there for people to consume. And if you've worked with that data, you kind of know the inherent ups and downs of what can happen with that. But there's also times when those portals just go down, or, now they're just getting taken offline for some, different reason and things like that. Now you have this factor of like this pipeline that you've used relies on data that doesn't exist anymore. So you really need to understand what those risks are, give some clear expectations of that, and then be able to create that data contract that says, here's what you can expect, here's the inherent kind of gaps and risks, and we'll alert you accordingly if something changes from that. I think if you have this debate between buy and build, usually where I start to draw the line there is really anything that can help you scale and bring down total cost of ownership. So when I say total cost of ownership, that's time or physical like stuff you have to maintain or manage and stuff like that. I always recommend starting by designing the base of a system and building the logic first. And there's great open tools you can do with that. Where I think you want to look at specific systems that can help you advance and scale is really around if you need to go to a larger scale or a more detailed scale, which kind of sounds contradictory. But if you have a large geography, like Australia is a pretty big place. You can't just do a simple query and expect it to work there. You need systems that manage that. If you need a more detailed scale, that could be frequency of the data, and you have to do that over and over and over again, or it's very small and granular. You could, a lot of satellite imagery might come in at 30 meters. Now, all of a sudden you need 2 meters or better to get a more detailed image. That balloons your compute and infrastructure costs. So picking specific data systems there that can handle that is going to be really important. So I think focus on those pieces first and use AI to help you get there. If you need AI to help you assist or learn or troubleshoot or whatever that is, it can help you do those things a lot faster than you could in the past. So if I'm looking back 5 years, like that's a huge indication, but I don't also want to repeat the same mistakes I saw before of like, I built this cool mapping application, but it only works for yesterday's data, or, it's the data haven't updated in 2 months. So, it's cool, but what else can you do with it? You got to be thinking about, kind of the consistency, the data contracts, all the stuff we've been talking about today. AI is going to help us build and develop and iterate much faster. And we're moving so quickly to that point again, that again, we're ignoring the bottom data layer. With bad data that goes in, there's going to be bad results that come out. And we're just kind of setting ourselves up for that again. So the models exist, the science exists, we know how to do these things. If you have a good foundation, the rest of that will fall down. If I could go backwards and pick out one thing I would tell myself, in a strange way, I would tell myself the same thing I tell people, which is pick a few technologies, go deep on them, really learn all those different pieces, but also understand how to communicate to people. Like, I wouldn't change what I would do there. At the same time, I don't think I would change a lot about my journey, because like, even though it took longer and there were like a lot of, kind of painful things you had to learn and stuff like that, by doing and making those mistakes, you kind of learn the right and the wrong way to do things. And I think all those lessons kind of help carry you forward and do stuff like that. At the end of the day, I think I would tell myself, if I'm talking to myself at this, just having graduated or something like that, I think really, get a good idea of how things work, how the systems work, and building that together, and then go pick specific areas to go deep on. The one I chose for me was like SQL and databases and processing of data. That's the one I ended up having the most passion out, more than machine learning or more than, some of the application development. That's the thing I really enjoy, because I know that everything, if you do that part well, everything else gets easier as you go from there. So I think that's probably, find that area that you really enjoy, go deep on that, but understand how it fits into the bigger picture.